seeing my video, I'm going to explain to you now how my application NeuralBond works, and I'm going to give you a demonstration. So this is the website. This is the page NeuralBond at .SAFT.Industries. This is secured, and so we have already this one connected with Phantom Wallet, which is this. You can get the address by clicking here and copy address, or you can open Phantom here to see the addresses that you have configured. So you have to have this in testnet mode, and I have various addresses here. So for this test, I'm going to be using these ones that are called cat and fox. So we can see here that Phantom is connected to cat. This is the address AK1, which you can see here, right? So one thing that I already did, but is the first thing that you need to do, is that you need to save the price to receive messages. So in this case, if I go here and I put a number in here, this number can be 0, but it's configured by default to this value. You can save the configuration so that other addresses can send you messages. So let's do that now and see what happens. So you can see here that NeuralBond is asking me to confirm this transaction. So I say yes. And it appears configuration saved. So every address needs to do this in order for it to be able to receive messages. The idea here is that I'm a creator. I want people to send me messages from the public, but I want to be paid for it to reduce spam. So I give them this address, and then if anybody wants to send a message to this address, they're going to have to pay the price in Sol that is configured here, right? And so I have the other address, which is Fox, that it's already configured to receive messages. So I'm gonna send a message to that address now. So we need the address of the recipient. So I already have that copied here somewhere. It would be this one. There you go. And then I need a message. Let's say test message for Fox, which is the name of the account, Fox account, because there are little animal emojis there. All right, and now I need my encryption key. So the whole idea of this application is to test. We know we can sign transactions with the Solana private keys, but we normally cannot encrypt data with them. However, there's a way to convert them to usable encryption, and so that we can use the same address to both sign the transaction and encrypt it and store it on the network on chain in Solana. However, we cannot get the private key out of Phantom programmatically. We need to ask for it, right? So the way you do that is that you open it and you go here into manage accounts, and you select the account and you say show private key. It asks for your password, and then you have to pass this ominous warning, and you get the private key and you copy it and you pay it. Now you're not supposed to do that, so we are gonna have to find a better solution long term. Maybe we'll have to see. There are some options to solve that, but the point here is to show that it works. So I already copied it somewhere, so I'm just gonna grab it, and then I'm gonna paste it here, and now I'm gonna send a message to my other account. So I click send message. This is encrypted locally, right? I say yes, send it. Okay, so let's log in into the other account. this. And let's check our messages. So we need to change the encryption key. Change, and then we say like this. Right, so what happened here is that you can only have one, in this version you can only have one active message per account. So you can see that this account already had a message from my sender, so I need to delete it so I can receive another message from this particular sender. So of course in a later version we can have like multiple messages per sender. Right, so the message is deleted, and let's go back. So I changed to cat, and then I connect address cat. Now I need to change my private key like this. Now test message for Fox, destination Fox. All right. Also, I can check if I have a message here. I don't. All right, so let's send it. Okay. You can see message sent. Now let's switch accounts. Go here. Fox, I connect. The address has changed, so I need to update my encryption key. Otherwise, the encryption is not going to work. So I sent the message. This is public key asymmetric encryption, right? So the sender encrypts with I'm the receiver. The sender encrypts with his private key and my public key. And I decrypt the other way around with his public key and my private key. So in this way, the private keys stay private, and we only exchange the public key information. And let's see, I go like this. There you go. There's a message that I just sent myself, and this was stored on chain, encrypted, and so nobody could read it in theory. We can see that like the program address is this one. So we can see that this was actually happening on chain. This is already on .NET. So these are the transactions that we just did. And you can see, if we look at this one, so let's look what's happening here. So this guy, this is my cat account, is sending the message to this other account, which is the Fox account. This is the program, and it's passing the configuration and the message address. And it's actually paying to the receiver. How much? I believe is this amount here somewhere. This one. This was a configured amount in the price, and you can see here that we're doing a transfer from this account to this account. So this was actually paid from the sender to the receiver, which is the point of this system, right? All right, there you go. Thanks for listening, and I hope you like it.